Hello, today we have 129 sum of root. Some root to leaf numbers. And you're given the root of binary tree containing digits from 0 to 9 only. Each root leaf pass in a tree represents a number. For example, root to leaf is 1, 2, 3, represents the number 123. Return the total sum of root to leaf numbers, the case is generated so that its answers will always be 32 integer. Leaf node is node with no children, and we have this example is very interesting. We have 495 plus 40, right? And plus 91. So we have 495 plus 40 plus 91, 626. Okay, 495 plus 40 plus 40. Oh, wait. Oh, okay. So this is like 495, 495. Okay, this is first one. 491, okay. Then 40. Okay, this is like this correct one. Okay, so this is DFS, right? And what we're gonna do, we're gonna do DFS. We're gonna, as we do in DFS, we're gonna pass nodes and accumulator. And as we do in DFS with node accumulator for every node, if we on leaf, we have some results, right? Declare some result value. And on leaf, we result plus equal, so we can accumulator use a string really quick. First, like str, no, we have to do int from ACC. And then we do on leaf and on step 3, we do DFS I left and I right. Also, we have to stop here if not I, then we will return. Very good. So this is gonna be like string conversion, right? String conversion. It's kind of like cheating a little bit, but let's implement this, and if we get it passed, I will think how to do how to pass. How it's called? How to pass 10 or 100 or 1,000. I don't know how it's called. It's like order of magnitude. Order of magnitude into this as well. But order of magnitude will be backward, right? It's 495, meaning, I'm sorry, meaning this is 0, this is 10, and this is 100. Excuse me. Okay, let's go with string first, and then I will think how to pass order of magnitude. Yeah, so let's implement it really quick. So we have res here, we have def dfs, return on leaf, meaning if I left and I right, if not I left and not I right, I right, then it's also interesting if you can, for example, have a list, right, and add this as a numbers, because there could be numbers and we added list and then we transform list into number, which is really good. I really like it, this idea. Okay, but first let's do like string, and then we call it and we return res. Maybe I forgot to add like yep. None is not valid, return type integer. Oh yeah, so I have to add accumulator, right? I'm not calling DFS here. So I have to call DFS and pass root. It's not valid for unspare, return type integer, return res. Okay, res equals 0 and ACC call with empty string. Non-type is always by return type. Okay, what is wrong with this thing? Okay, I see what I mean. Okay, 0 inspected 21. So if otherwise so tree node object has not attribute of left of it. Okay. Typo. Int. Cannot access local variable res because yep, so I have to do like self res. And let's do self res. Here and self res. So we also have somehow to add the thing into thing, right? So I mean we are not adding to accumulator anything, so we have to add ACC. Okay, let's do this like this, plus I11. Can only start to int. Can only concatenate str, not int. Okay, so we have two right here. And we can concatenate. Not like that. Str not really str. Ten minutes, done. Okay, so how about now transforming, um, I can create function, I really like that, so I can create function called um, list to number, and we accept list, and for e, I have to convert it backwards, right? For e in range, we can do L range from L to -1. Start and step. What we're gonna do, we're gonna create result which is 0, and we need to create so we're gonna be so if we have, for example, if we have 495, right, like a list here, 495, what we're gonna do, we're gonna 5 multiply by I, so it will be Li. Let's create one counter. Will be multiplied by 10 and by counter. So result plus equal, and at the end we return result. So instead of str, we create and ival, and here we're gonna do was to num acc, and here we just pass empty list. Looks legit. 9 append is not defined because it's supposed to be method name. List is index out of range. So if this is L minus 1, I can do here. And I also have to do, so first is 10. Okay, so first C is 1. Right, 10 power of C and C plus 1. So then we have 10 square. Oh, Python power. Python power operator. Oh, okay. Oh, okay, not quite right. Okay, so Here we have 25. And then we have 10 power 2, 10 power 0. Just 1. And we just add 5. Next, we increase counter and we get or instead we can multiply instead of power kind of like I by C. Pretty much the same. Okay, so what is the problem? Result. Let's do print. So this is what we have, and this is what we return. Oh, I understand why. Because if I'm passing, I cannot pass list in this case because I'm passing list, it will be passed by reference, and from first iteration it still be there. Yeah, I kind of cannot use lists. Let's scratch that and go back to our submitted thingy. How can I do copy to it? Okay. Yeah. So what else can I do? So in this case, I can somehow pass 495. At the end, it will be 0. Yeah, string is the best. Okay, I cannot think of any. If I return 495, return here, like, for example, depth. But it's 495, it will be 0 here. So 0, then I plus 1 and plus 2. So it's like return 0. But then I have to somehow wait for this one to return back. Yeah, I don't know. Okay, yeah, let's see how this is still work, right? Even if it's because of string, which is not beautiful and not fast. Let's see how it can be done better. Oh, it's a backtrack. Yeah, so this is how it's done. Return 0. New number is number plus root file. Okay. Oh, okay. But in this case, how do I know number? Okay, self backtrack root left plus root right. Root 0. This is nice. Backtrack on root, right? So we go if its root is number return 0. New number is new number multiplied by is number, which is here, multiplied by 10. Okay, so but we pass only number plus root value. Okay, if this is leaf, we return new number. And then we return self backtrack root left new number. Okay. Okay, this is definitely much better. I don't have to deal with the string concatenation and stuff. This is much more elegant solution. Okay, that's it for today. Thank you for watching.